All right, this is continuing with the material from class 11, and this is sample problem 4.2. Also a very, very typical FBD type of problem. We do a lot of beam stuff, especially in mechanics and materials. So they tell us that this P right here is going to be 15 kips. I don't like the unit kips, but we'll get over it. And there's we want to figure out what the reactions are at A and B. We'll notice there's no forces in the x direction, so there's not going to be any reactions in the x direction in this particular arrangement. So I declare my FBD. This is an FBD. And I declare what my x and y are going to be. And then I draw my beam. Now I'm going to put the loads onto it. So I got a load right here. That's 15 kips. It's a stupid name for a unit. And then we're going to have these two loads, and each of these are 6 kips. Maybe I met a guy named Kip once, and I just didn't like him or something. I don't know. Okay, so those are all the loads that are on here. Now here's the reactions right here, and I will place them there. And I'll label them as RAY, that's Ray, and RBY. And then I'll put in some dimensions into there. Here is 3 feet. And here is 6 feet. Here is 2 feet. And then another 2 feet. Okay, and so now we're ready to go. And so I will take the sum of the moments, and I could choose either A or B. By the way, if we were going to be technically correct, we would draw in this reaction right here, this RBX, because this is a pin joint. It can handle an X reaction, whereas A can only is roller joint. It can only handle a vertical direction. Sometimes, actually, this kind of situation, you have to be careful. Depending on the length of this, could be a teeter-totter, and this thing actually might need to be the kind of joint that would be able to handle tension as well as compression. But hopefully this P is sufficiently large enough, it can overcome the tilting, if you think of the seesaw kind of idea that's going on there. And that's a good analogy to look at for things. I like maroon sometimes here. So we take the sum of the moments, and what did I do? I decided to take it about A. I'll often choose the one on the left. It just seems like a good place to start. Sum of the moments about A. And so we proceed from left to right. We could see that the P, which is 15 kips, is going in the clockwise direction. And I'll just keep the thing in the units that we're given right there. There's just remember what they are, and then what the answer is going to be in. And that's going to be times 3. We take a look at the reaction at RB, and that's going to be in the counterclockwise direction as drawn. And we're predicting it's going upwards, which is a pretty safe bet. And so that's going to be times 9 feet. 3 plus 6 is 9. I can do that math. And then we have 6 kips over here, and that's going clockwise. And that's going to be 3, 6, 11. Right. And then lastly, we have another 6 kips, and that 2 is clockwise, and that's 2 more, so it goes 13, and that's going to be equal to 0. See, what we've done right here is we've written this whole thing out, as it was written up here, we wrote it down here. And then we solve for this, and we get RBY is going to be 21. And we know that the units are kilonewtons because all those there's feet all the way through all of these, so that all those feet cancel out. And I wrote kilonewtons, and that was silly because these are kips. That's how much I don't like kips, is that I wrote kilonewtons. And I got a positive answer, so I can go ahead and just put an arrow next to it and go upwards. I wouldn't do that if it was negative. I'd rewrite the thing out. And now I could take the sum of the forces in the y direction, and you notice I'm always declaring what positive is as part of that, because some people will take a shortcut sometimes. Looking from left to right here, we see that we got Ray, and and then we go downwards with 15 kips, and then we're going upwards with RB, but we already know that, so let's go our 21, and then another downwards of 6 kips, and then another downwards of 6 kips, and we're left with RAY is equal to 6. And if you have, and that's kips, and it's positive, so we know it's up, so we can box out our answer, yay. A lot of times it's better to summarize this at the very bottom with the answer. It really helps, but as long as it's only boxing up the answer, I don't mind. In an alternate universe here, we didn't have, if we weren't sure, we could check ourselves by taking this instead the sum of the moments about B. Like we don't need to do this, but if we wanted to check, this should come out and give you the same exact answer. So if you do that, what you have now is you will notice that RAY is going to be in the clockwise direction, and it's going to be 9 feet away from B. And then we see that, oh, the 15 kips is now in the clockwise, a counterclockwise direction, and that's going to be times 6 right here, right? And we skip over the B because that's where we're taking it about right now, right? And then we say, oh, well, now we're going to have negative 6 kips times 2, and then we have a negative 6 times 4 because that other one, that's also clockwise. And if we run this through, we better get, and we should actually do the math through there, we get 6 kips upwards. All right, so we get the same thing. So it's a good test, just to double check. If you think you did something wrong, take the extra moment to check the other way. Maybe if you're during an exam, you finish up with this answer, you finish up with your other problems, and you come back and you do this, but you don't waste the time because you want to make sure you finish the exam before you go back and do checks. So that's it. How do we do on time? A 7-minute video. That's a good length for a video. I'm happy with it. I hope you are too.